This entire Homelab rack took less time to cut than a set of these corners take to 3D print. Today we're going to find out whether laser cutting is a good alternative to 3D printing for a Lab Rax Homelab. Lab Rax is a 3D printable 10-inch Homelab system, and over the last year it's become one of the most popular projects on my channel. But during my recent move to this new workshop, I found myself staring at a stack of plywood sheets I uncovered, and I wondered whether there was another way to build one. Laser cutters are incredibly fast compared to 3D printers. They're great for producing flat-back components, and the new M2 that xTool sends over for a project can not only cut the parts out, but it can actually print directly onto them too. So today I'm going to try convert the Lab Rax design into a laser-cut wooden Homelab system, while still keeping the parts compatible with the original 3D printed version. So let's get building. The first step was converting Lab Rax from a 3D printable design into something that could be laser cut from flat sheets of material. Rather than redesigning it from scratch, I wanted this version to look as close as possible to the original Lab Rax design, so the overall dimensions, shape and styling are all based on the existing design. I also wanted the racks to remain cross-compatible with the 3D printed ones. To do that, I started by creating a flat pattern in Inkscape. Every panel, slot and mounting feature had to be laid out as a 2D profile that can be cut from some 3mm plywood. One neat feature of laser cutting is that you can create strong structures using interlocking tabs and slots. So instead of relying on screws or printed brackets, many of the joints are designed to interlock before being glued together. After an hour or two, I had a complete set of panels ready for cutting. Before we cut them out, I wanted to add a bit of Lab Rax branding. This is where the xTool M2 really allows you to build interesting projects. Unlike a traditional laser cutter, the M2 combines printing, laser cutting and engraving into a single machine. For this project, I'm using xTool's print and cut workflow. The process starts by swapping to the printer module. This allows you to print graphics directly onto the plywood surface. I created some Lab Rax branding and decorative elements that would normally require stickers, decals or paint masks. Being able to print them directly onto the material makes the finished build look much more polished. The M2 has a pretty clever head design. Rather than fiddling around with screws and cables, each module is held in place magnetically and just requires a single USB cable to connect it. So swapping between modules takes a couple of seconds. Now let's get the first panel printed. Once the printing's finished, it's simply a matter of swapping over to the laser module, and then we can run the cut job to cut the profiles out. The machine I'm using has a 10-watt laser module installed, but xTool also offer a more powerful 20-watt module, as well as a 3-watt infrared module. All of them are designed to swap onto the same gantry system. Now let's get the second side panel made up. The working area of the M2 is impressive for its overall size. It's 610 by 569mm, or a little over an A3 sheet of paper, which is a huge step up from the original M1 that I used previously. It gives you a lot more flexibility to work with larger project parts like these. After about an hour, the M2 had produced a complete set of Lab Rax parts ready for assembly. One thing that anyone who's used a laser cutter knows is that cutting wood creates a lot of smoke. That's something xTool has put a lot of effort into addressing. The M2 is fully enclosed and can either be vented outside through a window or connected to xTool's new SafetyPro AP2 Air Purifier. And this thing's impressive. The filtration process starts with a layer containing 36 cyclones. These separate larger visible particles before the airflow passes through 5 additional filter stages. The final stage is a HEPA filter capable of removing 99.97% of particles. What makes it even more convenient is that it connects to the M2 over Bluetooth. The air purifier can automatically start and stop with the machine, and xTool's Creative Space software adjusts the settings based on the material that you've selected. It's a really neat setup that makes running a laser cutter indoors much more practical. I've cut all of these parts in a small workshop. An air quality monitor didn't register any significant changes over an evening of cutting. With all of the parts cut out, it's time to find out whether this design actually goes together as intended. I'm just using some basic wood glue to hold the pieces together. Unlike a 3D model, these flat designs are a bit more difficult to visualize how they'll fit together once complete, so there's more room for error. Assembly is pretty straightforward. I started with the two main side panels and then slotted the top and bottom sections into place. The laser cut tabs help align everything with a small amount of wood glue holding the joints together. Once the main frame was assembled, I added the vertical rack posts. These contain all of the mounting holes and are what make the system compatible with the existing Lab Rax ecosystem. Finally, I installed the corner pieces that give the rack its distinctive Lab Rax appearance. These also help square up all of the parts. I then flipped it over to do the other side. At this point, it was already looking really similar to the original 3D printed version. The last addition is the laser cut handle reinforcements. These strengthen the handles and make them a bit more comfortable to carry when the rack is fully loaded. With the main rack complete, it was time to cut and assemble the rack trays. For this first test setup, I'm using a fairly typical Homelab configuration from my first Lab Rax build. At the top is a mini PC, below that's a TP-Link network switch. Underneath the switch is an SBC shelf with 4 Raspberry Pis installed in it, and finally at the bottom is a slim NAS. I've also got a large 120mm fan at the top to provide some cooling to the rack. Just like the rack itself, these trays are adapted from the original 3D printable versions, so they're all cross-compatible. The designs were modified to suit laser cut construction while still maintaining the same overall functionality. The print and cut workflow came in handy here again. I added labels and graphics directly onto the trays before cutting them out. These then glue together much the same as the main rack. Now let's get the hardware installed into the trays. With all of the equipment installed, the wooden Lab Rax Homelab is now complete. I wasn't sure how this project was going to turn out when I started, but I wanted to see whether a system originally designed for 3D printing can be successfully laser cut, and it's come out better than I expected. I actually quite like the light wood look. It's recognizably a Lab Rax Homelab, it's compatible with most of the existing components, and the opposite is true too. Best of all, it can be produced much faster than waiting for 3D printed parts. The only thing that's a bit fiddly is installing the screws, because you can't use brass inserts like on my 3D printed racks, but that could easily be adapted to use square nuts or rack studs. I'm interested to hear what you think of this rack. Would you build a laser cut version like this, or do you still prefer the original 3D printed design? Let me know in the comment section below. A big thank you to xTool for sending over the M2 to make this project possible. If you'd like to learn more about the M2 or the SafetyPro AP2, I'll leave links to them in the description below. If you enjoyed this project, make sure to give the video a like and please subscribe for more tech and electronics projects, tutorials and reviews. Thanks for watching, and I'll see you in the next one.